Well, so my name is Kopecek. I'm in PV now since 26 years, and I know this because I spent half of my life to photovoltaics. So I'm the co-founder and director of ISC Konstanz, and I will show you some slides about that. But as we already talked about, I think it's more and more important that Europe will go into PV production, and I will show you how, because it's clear now the hunger for modules is out there, because PV is the king of energy markets, but it will not be possible actually for China to supply modules to the rest of the world. So we need local production. So the title is PV Made in EU, the returning importance of local production and emerging technologies, like what will be happening the next 10 years. I've been to the SoliTek conference in 2019, and here you can see the proof actually, what you already told, that SoliTek is one of the pioneers of many technologies. So bifacial, agri-PV, Julius was already reporting about that at that time. And after the conference, I call it workshop, but you call it conference, you already also reported that you will partnership with Valoe cell and go into IBC solar cell production. So actually, let's say you are producing solar cells under this roof, but it's a different company. It's Valoe cell, and they are producing IBC solar cells. So the contacts are both on the rear side. I will show you some picture later on. So it's a fairly not new technology, but not many are producing this technology so far. So Lithuania can be really proud that to have SoliTek, and I'm happy to see that you have so many companies that you are expanding also to storage, because this will also guarantee the success of photovoltaics. Because if we want to roll it out really at the 1 terawatt scale yearly production, we need storage, hydrogen, and different possibilities to actually store the energy that is being produced. So here are two examples what SoliTek is also doing. You named it. You were one of the pioneers of bifacial tracking and also to conditioning the ground, so putting some white foils underneath the modules, which increase the albedo and the total power. So 40% of additional energy yield. It's amazing, and I think it also pays off, even if you have additional costs, of course, with the tracking and the foils underneath. And what Valoe is doing, I told you, IBC solar cells, and they are mostly cooperating with the Sono Motors to put the solar cell into the car body. So that means in future we will not have only electric cars, but also self-charging cars. And the idea here is, if you have like the entire hood equipped with a very effective IBC solar cell, so if you leave the car outside, you can charge 30 kilometers a day. So if you are using it only in the city, there is no more charging in future of the car, which is quite interesting. Of course, it's a little bit more expensive, but it pays off in future. Good. So 2022 is a perfect year for photovoltaic. As I told you, the hunger is there. Since 2020, PV became, with the PERC technology, the king of energy markets. And in March this year, we installed a total capacity of 1 terawatt. And the plans are huge. So Europe wants to install this year 60 gigawatt, which is about 2 to 3 times more than last year. You know the reasons. We want to get independent of energy import. So Germany has big goals to install 20 gigawatt yearly, which is amazing. And the question is actually who will install that, because We don't have the manpower, we don't have the qualified people, so we have to train where to install. So double use of land, this will be very important, like agri-PV, where you can use the land 2 times. And the main question for me is also, where do the modules come from? And as I told you, local production will be extremely important for that. And US wants to install 70 gigawatt, China 80 gigawatt. So this year, people are expecting that 250 gigawatt will be installed. And but still, this is the beginning of the PV story, because if you learn from the past, what happened in the past, and this figure was made by PV magazine from the data of Bloomberg. So it's quite easy to see that every 3rd year the PV production is doubling. And this happened from 2080 already on. So if we learn from the past, and I think we will even accelerate now, that means that in 2028 we will enter a yearly 1 terawatt market. That means the capacities these days are at about 300 gigawatt yearly, so we have to triple this, and that means that there will be room for new investments and new factories out there. So US now has some good policies to really accelerate the PV production again. And I think we will hear from Sigimantas what will happen in Europe, and hopefully we will be successful as well. Yes, so the content, ISC constants, I will show you 5 slides, then some arguments about PV in EU, and also show you the most important players in Europe, then about PV technology, and at the end I will show you just some example for bifacial PV. So ISC constants, we are founded in 2005. This were the golden time of photovoltaics, where we cooperated with SolarWorld, Bosch, like there were many producers. And when everything went to China, ISC Constants was there involved then in technology transfer. So transferring our technology that we developed with Bosch, for example, the N-type technology, to India, China, but now also to Valo. And we are focused on solar cells, module and energy systems, but do not have different companies, but departments. So we are involved in technology transfer of PERC technology. This is the main technology now that SoliTek is producing, TOPCon and IBC solar cell concept. Yes, these are our references. So we started technology transfer after Bosch stepped out in 2015. So we bought our common patents and transferred one technology to Megacell. It was an Italian company, then to India. Yes, undisclosed Asian customer, it was REC. Then SPIC is our biggest customer at the moment. And as I told you, Valo. Here under this roof, they are producing IBC solar cells. What will happen in future? So we are cooperating now with RCT. That's also a company in Konstanz that is actually doing the whole factory planning, and we are supplying the technology. We have now a contract with Insola, so we will transfer our IBC process to Mauritius. It's a nice place to go. So we will have no problem with our technicians to go there and do the technology transfer. Then Avada, it's a company in India. In India, there are many things happening now. Carbon, maybe you heard about it, that's a big French consortium. They now want to go into production, and not only 1 giga or 5 giga, but 20 gigawatt. They have big plans. Yeah, let's see what will happen there. So here's still the old number, 5 gigawatt TOPCon, which the technology transfer will start end of next year. Yes, here I took the picture as an example for a modern factory. Hopefully there will be more factories like that built also in France and Germany for large gigawatt cell production. So not only batteries but cells. Yes, why we should install more capacities in Europe. You can see it actually in this graph that after a dip in the last 10 years, so unfortunately we lost 10 years, not only in Germany but in Europe because of bad policies. But now things are back on track again. So last year in Europe there were 26 gigawatt installed. As I told you, now for this year the plans is to go to 60 gigawatt, and that's why we have to increase the production in Europe. So China just cannot produce cells and modules for all the countries anymore. And I think that the big EPCs and companies that want to install modules are already feeling it, that there is a lack of modules out there, and it will be even worse in future. So here you see in 2020 the capacities of the entire value chain. So let's say on the module side, I think it's already 8 gigawatt. So we have 8 gigawatt module production in Europe, which is okay. But of course, we have to import many modules if we want to install 60. But on cell side, ingot wafer side, there are really low capacities, and mainly solar cell side. And this is my mission now with the European Solar Manufacturing Council and Sigimantas in lead for the politics to bring photovoltaic back to Europe. And but Europe is quite slow with their policies. I mean, in US now, President Biden signed a contract for subsidizing production in US. This is unfortunately not possible in Europe. But I'm quite optimistic that we will also make some good decisions. So here you see the new initiatives in 2021. What happened? There were many announcements out there. So for example, Meyer Burger was announcing to go to production, and they actually succeeded. So here in green you can see which projects were successful or which projects are online. REC, they have big plans to go into heterojunction production in France. Greenland Gigafab unfortunately is now on hold. Energetica was insolvent, but I think they are restarting. And there are also some tandem activities. Oxford PV is planning to go into tandem production. I will tell you later on what this technology is about. But as I told you, Valoe cell with under the roof of SoliTek are also producing cells, IBC cells, and Energira, that's a company from the Netherlands, is also producing IBC modules out there. The new players, for example, I think you heard the news that NL is now going to gigawatt production. As I told you, REC, Carbon now are making advertisement for 20 gigawatt, and they really mean it, and they go vertical integrated, like starting from ingot to modules, because if you start a solar cell production only, maybe that you will not get the wafers, because if you want to be really independent, you have to produce vertical integrated, like all the products. And it's not only about wafers, but it's also about polysilicon, about glass. And this is what we are now starting in Europe, actually, that to build a big consortium also to go into production, similar to the Airbus that we did like with France and Germany a couple of years ago. And there is also a company in Turkey, Kalion PV, that increases their capacity now to 2 gigawatts. So they are producing already 1 gigawatt vertical integrated PERC from ingot to modules, And now they are moving, similar to SoliTek now, also to N-type technology, to TOPCon. Yes, I think I can skip these slides. Sigimantas will tell you more about it, what is necessary in Europe, what kind of measures do we have to take in order to bring PV production back to Europe. And yes, I can skip this one. We have now a big European project with many partners, mainly also machine builders from Germany, Rena, Centrotherm, to develop a new version of the IBC solar cell. We call it IBC for EU, and we are quite sure that actually this technology can be a strong argument to bring PV production back to Europe again. And about the PV IPSAI, which we are now doing, I think Sigimantas will report more about that. So, but in very general, PV IPSAI is an important project of common European interest. And if Europe agrees that photovoltaic production is important technology, which they already did, and countries, for example, like Lithuania is very committed, Spain, and we are now in the process to submit proposals also for the new technologies that will be produced in Europe, and then Europe will be in future able to subsidize PV production. Like the countries where the commitment comes from, they will be able somehow to subsidize, which is not so easy possible in Europe. You will hear more info about that. Okay, and when for an important PV technology to be really successful, we have to do it all together. And this year in Milan, in September, there will be a world conference on photovoltaics, and for the first time after a couple of years of PV desert, the exhibition is now fully booked. So I am very happy that we will meet there and discuss how we can really achieve to bring PV back to Europe. Okay, so these were quite political things and some information about what is happening in Europe, but now about PV technology, and I call it always entering the bifacial N-type era, because P-type, like the PERC solar cells, they come to their efficiency limits, but now it's time for N-type technology, and I will tell you why. So on this slide, you can see the fast drop for prices of PV modules. Unfortunately, from last year to this year, it was the prices after 10 years or 15 years even of constantly dropping. Now it goes up again a little bit, and this happened also already in 2005. That's mainly because of the so-called polysilicon crisis. That means at the moment the major bottleneck for PV production is pure silicon, and we will solve this, let's say, in middle of 2023, because by me I mean the PV industry will solve it, because big expansions in China of polysilicon production by the Siemens process. But maybe you heard about it. There's a big discussion now, should we buy polysilicon from China because of forced labor and things like that. So we need actually also to install more polysilicon production in Europe. And we have a big polysilicon producer, which is Wacker, but they normally use also this material for electronic industry. So we have to convince Wacker to scale up their polysilicon production. But nevertheless, even with module prices at 30 cents per watt peak, it is possible to reach, in some regions like in the MENA states, electricity prices of 1 cent per kilowatt hour. That's simply unbelievable. And we are at the beginning of the journey, so it can be even below that, and I will show you how. So how is 1 cent per kilowatt hour possible? As I told you, PERC is the king of energy markets these days, and that's the major product of SoliTek. So if you look at the modules 10 years ago, not only, let's say, the power was smaller, but also the design was kind of different, like full cell and smaller modules. Now we have half cells and so on. So the modules are at lower cost because of higher power, more efficient front side, but also about bifaciality, because of bifaciality. And if you combine it with the lower cost of balance of system and also tracking, then 1 cent per kilowatt hour is possible. Of course, the average is not 1 cent. In Saudi Arabia, they have different financing models. So the average is about 3 to 4 cents per kilowatt hour these days. But how can we go even below that? So that means you have more kilowatt hour per kilowatt peak for the PERC module compared to the aluminum back surface field. And how can you go even below that is to go to not a different technology. It's very related to the PERC technology, but you are changing the N-type substrate and also partly the process. But let's say the PERC production sites can be upgraded. And then you have even more efficient modules. You have seen the forecast of the power. Then very important is also less degrading and with a lower temperature coefficient. That means if you are increasing the voltage of the module, then the temperature coefficient is lower. That means if the temperature is getting high during noon, or let's say in MENA states, then the power is still at the same level with higher voltages. Or let's say it's not going that low as for P-type. And the modules will be more bifacial as well. And it will be also interesting in future to do the more albedo enhanced measures that means to make the roof white, for example, or to putting some sheets on the bottom. And that means going to N-type, again, you have more kilowatt hour per kilowatt peak. And if you look at change at the switch from aluminum back surface field to PERC, that happened in the last few years. Here you can see the cross-section of a typical PERC solar cell. The efficiency in production is at 23%, but as I told you, PERC is now coming to its efficiency limits. And here you can see typical parameters of a PERC solar cells at M10. This is the wafer size. That's, I think, 180 times 180 or something similar. So what will happen in future is that we will have a similar change to N-type now. So this is the PERC, and we are now in 2022, so about 10% of the market share is N-type, but analysts believe that it will be also a fast change now to N-type, similar as for aluminum back surface field and PERC. So this is, I would say, the most important slide for you to understand. It's a technological slide that here you can see the yearly improvements of the efficiency on the PV market. And as I told you, in 2016-17, the aluminum back surface field came to its limits, mainly because of the rear side passivation. So actually every improvement is based on better quality of the passivation of the solar cells on the front and on the rear side. And so what actually mainly changes is the voltage. So for aluminum back surface field, you had voltages about 660, a little bit more. Then for PERC, you can go to 680, maybe 85 with selective emitters. But to go above 700 millivolt, you have to change to N-type and to so-called TOPCon technology or heterojunction and IBC. And there you can see also that you are not only, let's say, passivating the rear side better, but also the bifaciality is enhanced. That here you can see the open side of a PERC solar cell, and because you are using aluminum, so the bifaciality is about 0.7, and here you can go even to 0.9 or even above that. The question is, so this is what will happen, I think, in the next 10 years, and what will happen then? I'm not sure if the technology, if PV industry will go to tandem. This is quite unsure, because these days tandem technology based mostly on perovskite on top, they are not very well developed yet. Many people say that this technology is already mature, but we are organizing tandem workshops, and when I listen to the maturity of the tandems, it's not there yet. I mean, there are many record efficiencies announced above 30%, but these efficiencies are on small areas, so you have to scale up the size. You have to take care about the lifetime of the perovskite, because they are degrading quite a lot, but that's not the only thing, because, for example, also the reverse behavior is not very good. So yeah, let's see what will happen there. I very often compare it with the mobile network. So going from 3G to 6G. So 3G, as you know, is already obsolete. Nobody is using it. Some production in India use still aluminum back surface field, but that's because it's a lower cost technology, but it just doesn't pay off in future. Mostly we are running these days at 4G, but there's a switch to 5G. If 6G will come, nobody knows. So here you can see the cross-section of all technologies, PERC, TOPCon, heterojunction, and I don't want to bother you with too many details, but you have here you have the processes sequences, so these are the processing step, what you need in production. Of course, PERC process is a little bit more lean than TOPCon or heterojunction and IBC, but it's not only about efficiency, it's also about throughput. So you have to guarantee a good throughput, yield, and also module implementation. And let's say for heterojunction technology, it looks very simple, but the devil is, as always, in the detail. You have only low temperature processes, so in order to make really good modules, you need a different module technology. So we are very sure that actually the next big thing after PERC will be TOPCon, and let's say IBC is actually the holy grail that everybody want to have at the end. But at the moment, for many companies, it is just way too complicated to go straight on to IBC solar cells. So here you have the pros and cons of every technology. So the efficiencies are increasing, and as I told you, PERC is the working horse, TOPCon is the major challenger. I believe that heterojunction will stay still at the niche markets, but the interesting thing is here that they have the highest bifaciality. And this is the holy grail, actually, that after 10 years development, I believe that after 10 years, everything will run on IBC technology. Here you can see the pictures of the solar cells from the front and from the rear. The IBC cell is, of course, different from the others, so you don't have any metal on the front side, but both polarities on the rear side. Here you can see the modules. IBC technology can be also bifacial, even if there is quite a lot of metallization on the rear side. But let's say all technologies look, of course, in modules quite similar. If you look at the highest efficiency modules out there, so The highest efficiencies, of course, are N-type technologies, but for the moment they are still a little bit more costly than PERC, and that's why they are used mainly for rooftop application or for building integration. And what is happening in China, that actually the tier 1 manufacturers like Q-Cells, Jinko and Trina are moving to the TOPCon technology. And let's say new investors are maybe going into heterojunction to have, let's say, a different technology. But the biggest PERC producers are changing to TOPCon because, let's say, the TOPCon technology is very similar to PERC technology. And here you can see some forecasts about the capacity. That means in 2025, and I believe it will be more, is that N-type technologies will have a breakthrough. Future material challenges, as I told you, polysilicon. We are currently in a polysilicon crisis. Silver has to be reduced because of N-type technologies are using silver. Heterojunction has one more disadvantage, is the indium that is included there, and also glass and aluminum. If we enter a yearly 1 terawatt market, will become not a problem, but a challenge. And it has been also mentioned by SoliTek that circular economy with effective recycling will be more and more important, of course. Yes, I already told you, Tandem Technology, there are many high efficiencies out there, even exceeding 30%, because putting another semiconductor on top of silicon, you can go above the Shock-Liquefier limit. But the challenge is the stability and many other challenges. Nevertheless, I explain you very shortly the different arrangements of Tandem Technology. You can go for 2-terminal, where you have directly on the silicon the perovskite, and you have like the polarities on top and bottom. If you are using an IBC solar cell, you have a so-called 3-terminal solar cell with 3 polarities, or more or less we are putting 2 modules on top of each other, and then you have 4-terminal. I'm a big fan of 4-terminal, even if you have, let's say, 2 modules on top of each other, which sounds costly, but it's, I think, the easiest way, because you don't have to do the so-called current matching. Here you have to adapt really the 2 semiconductors towards each other, and that's extremely complicated. So putting 2 modules on top of each other makes more sense, and also you can have quite good bifaciality for this kind of arrangement. But I think it will take more than 10 years that this technology will be visible. What I mean by visible is that we have about 5% market share. Of course, there will be companies like Oxford PV with some niche applications for rooftop or for maybe car applications, but really in big scale, it will take a lot of time. How much time do I have? It's 5 minutes? Ah, that's perfect. So now I show you some pictures of bifacial technology. Yes, here you can see how it works. The front side is still more important than the rear side, of course, but you have, depending on the cloud or of the albedo of the ground, quite a lot of power also coming from the rear side. And when we started to do advertisement for bifaciality, it was already in the year 2000. There were not many believers because they were selling modules without any problems. Doesn't matter if it was bifacial or not bifacial, but in 2018, then people were thinking to diversify from the other producers and going bifacial. I think the biggest company at that time that really made the difference was also Longi, a big producer that were saying that bifaciality will be the future. And in Europe, SoliTek was one of the pioneers that brought bifacial modules on the market. But from now on, I think it's quite clear that bifaciality is the winner, and not because it's a big revolution, it's just a revolutionary process. I told you the evolution of the solar cells. They become bifacial anyhow, and people are making glass modules anyhow, so it's just a logical consequence that bifaciality is gaining importance. And here you can see the bifacial cells and the forecast for international technology roadmap. I think it will go even faster, but if it will go as they are forecasting, so in 2028, I told you we will have there already a 1 terawatt market, and 600 gigawatt from that will be bifacial. And of course, there are different arrangement of bifacial photovoltaics. Here you can see a monofacial cell in a monofacial module, and then you don't get any benefit from the rear side. You have even a benefit if you put a bifacial cell into a monofacial module. And if you have, let's say, still a spacing of a couple of millimeters, then the light can also penetrate into the rear side, mainly also in the morning when you have a very shallow incident. And there you can, even in the monofacial module, get benefit from the bifacial cell. But of course, most sense, it does make sense to put a bifacial cell into a bifacial module. And bifaciality started with fixed tilt, N-type. Then at a certain time, horizontal single axis tracking was out there, also implemented by SoliTek or by Enel in Chile. These were the first ones. And then the big breakthrough of bifaciality came when bifacial PERC came on the market. So the bifacial PERC made it really a big breakthrough, but now we are entering, as I told you, a bifacial N-type era. So the PERC technologies will be substituted by N-type technologies. Yes, you can see some bifacial arrangements. So bifacial tracking, we already talked about, that you can have the largest production curve if you make an integral, or if you are installing vertically. This is also quite an interesting arrangement, what we do with our partner next to in Germany. You have a quite an interesting shape of a feed-in curve, so you have quite low electricity in the afternoon, but quite a lot in the morning and in the afternoon. And you can also use the land 2 times, because the ground coverage ratio is almost close to 0. So for electromobility, it does not make sense to make bifacial modules, but somehow it does. For example, for some carports, their bifaciality makes a lot of sense. Here you can see the IBC, bifacial IBC at ISC Konstanz, or we lately installed bifacial IBC on a roof of an electric ferry at Lake of Constance. So, of course, the ferry has to charge still, but it's an additional electricity for the ferry, and it looks quite nice. For standard rooftops, bifacial modules do not make a lot of sense, but for the balcony application, what is now more and more installed in Europe, it makes sense to install bifacial modules, because you can have like reflection also from the wall. You can also go for flat rooftop application. Then bifaciality also makes a lot of sense. If you, for example, also condition the roof, you can paint the wall white, or you can even do tracking on flat roof. Of course, you have to have a quite stable rooftop. Then this is what I told you before. This is an example of vertical installation on a roof, or some building integration. This is a building in Milan with our Bison technology. Then floating PV is coming. Unfortunately, water is not a good reflector, but still you can have, let's say, 3 or 4% additional gain on floating PV. And agricultural PV, you will hear more of that, more about it in next talks. You can go vertically or you can go above the crops or the trees. Yes, you already talked about it, that N-type bifacial is not only for buildings. Now it's more and more penetrating into the utility scale market, and Jollywood, for example, now installed a large 700 megawatt system in Oman based on TOPCon technology, and as you can see here, I think they are copying SoliTek. So Chinese are also copying Lithuanian technology, that they are putting white reflectors below the modules. So my last slide, more or less, when I come to conclusion, is that my dream is to have in future modules, N-type modules of 23% efficiency at a very low temperature coefficient, bifacial factor quite high, and lower degradation. And the modules, I think they do not have to be too costly. It's not necessary to see modules in future for 10 cents per watt peak. We can stay at 20 cents and improve the properties of the modules, and still you will get an advantage, and you can go below 1 cent per kilowatt hour in large utility scale systems. So the 4 takeaways for today, not 3 but 4. So more modules will be needed in future as current production allows. So actually local production is extremely important. Bifacial PERC at the moment is the king of energy markets, and we will see more 1 cent per kilowatt announcements out there, of course mainly from the MENA states. The average is at 3 to 4 cents per kilowatt hour. Bifacial NPV will be the new emperor, and SoliTek is prepared for that. So TOPCon heterojunction will be used, and IBC is then, let's say, the winner. And Tandem Technology is still will need about 10 years or even more to come into the market. So there we need some upscaling and stability issues have to be solved, and also reverse behavior and similar. So thank you very much, and I would like to invite you to the World Conference in Milano. As I told you, the fair is fully booked, so come and discuss with us how we can start PV production in Europe. Then, if you are interested, come to our bifacial workshop to Ankara, also to look at the vertical integration of PV factory, and back contact workshop we are organizing this year in Constance. Thank you.